My name is Jeff Rosenfeld. I'm the editor-in-chief of the Bulletin of the American Meteorological Society. And here at the AMS annual meeting, I am with Joe Bassi, who is the author of the most recent AMS book called A Scientific Peak: How Boulder Became a World Center for Space and Atmospheric Sciences. Now, we all know about Boulder, but we're going to find out a little bit more about the book today. So, Joe, hi.
Hi, I'm glad to be here, Jeff.
So, tell us a little bit about your background and how you came to write this book. First of all, are you a meteorologist, or what's your science?
I cover a couple of bases here. I actually started out as a meteorologist from Penn State, graduate degree, as an Air Force officer. But then during my Air Force career, I kind of segued into space environment and space operations support. So I did a lot of that in the Air Force, in addition to going to University of Colorado, speaking of Colorado again, to work on degrees in astrophysics. And then I went to teach at the Air Force Academy for a while. Segue on a few years, I was director of the Joint Typhoon Warning Center. Then after another assignment or two, I retired from the Air Force and went after a passion to pursue a degree in history. So I got a master's at George Washington University in American history, and with some science policy thrown in. And then I was fortunate enough to get a National Science Foundation fellowship to work on my PhD, and I did that at University of California at Santa Barbara. And so what you see in the book is actually an artifact of my PhD dissertation.
So you just finished your PhD at this point. Did they hand it to you yet? I mean, when you get a book like that, it's kind of hard to resist, right?
Actually, I finished my PhD in 2009. So this has been a while. I went off. I did some work for the Air Force for a year as a contractor with the Aerospace Corporation. Then academe popped up, and I took a job teaching at Embry-Riddle Aeronautical University worldwide campus, where I still am. So turning the dissertation into a book had to wait a while. But after 3 years, things calmed down a little bit. And so I put together a proposal and spoke to some people at AMS, and here we are with the book.
So I guess the first question I have to ask before we get into the book is mid-career changes and following your passion. Why did it take so long? And now that you've done it, is it ever too late?
Sure. Answer the last question first. It's never too late. But to answer the first question, long is a relative term, is it not? And given a normal human lifespan, I did 26 years in the Air Force, where I was basically pretty happy serving the country and doing lots of interesting things. So that was the first part of my career. Now, military careers are kind of unusual in that for the average person, you're going to retire in your mid-late 40s. So you kind of have to have some sort of plan on what am I going to do next. And so I, for a long time, with encouragement from both civilian and Air Force historians, thought that once I retired, I would head off and pursue one of my passions, which is history. But I love history and science. So I didn't want to go do French medieval history. There's nothing wrong with French medieval history, but I wanted to stay in the world doing science, something I knew a lot about. So my PhD work and focus has really been history of science. So what looks like a discontinuity is really not that much of a discontinuity.
That makes perfect sense. In a way, it makes perfect sense that you would end up writing a book about Boulder because you spent some time there. But more importantly, your space weather background is unusual, it seems to me. I don't know how many people of your generation, and my generation even, which is almost the same thing here at this point, but how many of them really knew space weather was a specialty and how they got into it? How exactly did you get into space weather?
Again, that was an artifact of my Air Force career. I was started as a meteorology officer, but in the Air Force, space weather comes under meteorology. And so because I always loved astronomy, it was kind of a natural, quick segue. So even at Penn State, I was in meteorology program, but I did my thesis in ionospheric physics. And so that put me into doing space weather things very early in my career, and I kind of continued that as one of the sub-themes of my career.
So let's talk a little bit about that integration and what it means in Boulder. How did Boulder become a place where space weather and atmospheric science all sort of came together? It seems to be sort of the brainchild of one person, but there are many factors involved.
There's a lot of things that happen in life, as we all know, without real planning. One of the things that makes the Boulder story interesting, I think, is there's a lot of, to use a 25-cent word, contingency occurring. It wasn't as if a bunch of people or even a couple people or one person sat down and said, here's what we're going to do in Boulder. It basically happens. In my talk yesterday, I mentioned people often try to find some sort of cosmic or meta-narrative reason on what happened in Boulder. Simply put, Donald Menzel, Harvard astronomer, grew up in Leadville, Colorado, knew that was a good place for solar observing. 1940, sent his student, Walter Roberts, his PhD student, to set up the first coronagraph in the Western Hemisphere in Leadville, which is in the mountains sort of behind Boulder. After 5 years, 6 years in the mountains, Walt and his wife, Janet Roberts, decided they wanted to move to a place of more civilization. The nearest city that had a university of any kind was Boulder. And it's as simple as that. Walt Roberts brought SunEarth Science to Boulder from Climax, Colorado, because his advisor, Donald Menzel at Harvard, sent him to Colorado to observe the sun.
Obviously, it went beyond observing the sun. So how did that happen, and how did Walter or Roberts, as I hear it, but Walt Roberts, as you say it, you must have known him or met him.
I met him a few times in my graduate career when the Air Force sent me back for a second graduate degree to University of Colorado in the early 80s. But the book goes into some detail. A lot happens. Walt Roberts initially creates with Harvard and the University of Colorado the High Altitude Observatory. One of the primary customers of the High Altitude Observatory was called the Central Radio Propagation Lab, that did what we would call today space weather forecasting. So you have this nexus of the High Altitude Observatory and the Central Radio Propagation Lab. For various reasons in Cold War America, it is decided to move the Central Radio Propagation Lab out of the DC area in the Bureau of Standards. And it's a long story, but eventually it winds up in Boulder. So it's the next aspect of creating this place for SunEarth Science. But an important part of what I try to tell is the SunEarth Science really enables Boulder to branch out into many other sciences, because the SunEarth Science study has so many aspects to it. It's physics, it's chemistry, it's geology, it's astronomy, it's meteorology. So this platform initially of SunEarth Science lets Boulder explode literally in especially after Sputnik and the International Geophysical Year, into a place of many sciences and not just Sun-Earth study. However, Boulder still has a big component of its work as Sun-Earth study.
So IGY and this Cold War era brought a pre-existing interest in the upper atmosphere as well, and radio propagation, as you said. These were all there before the World War II, but with the Cold War, things really got hot, so to speak, scientifically. Can you tell me, as a historian then, as well as someone who's practiced these fields, did the proportions of interest make sense from a scientific point of view? In other words, the investment in those areas, did they overshadow other scientific fields that might have progressed in other circumstances?
Yeah, scholars discuss this and debate this to some extent. I think the main argument that you can make is that the Cold War prejudiced physical sciences over biological sciences. I don't think you can go much beyond that. Because some scholars try to argue that the military manipulated science, had a heavy footprint on science. I think the effects are much more subtle, and Boulder is an example of that. Absolutely, Boulder is a result of Cold War America. That being said, one of the things I argue in my book is that it is sort of amazing how little impact direct military policies had in Boulder in terms of developing Boulder. I argue one of the reasons Boulder flourished as a place of science because so little was classified relatively in Boulder. So you had a unique set of circumstances, the Cold War, and especially after Sputnik, pumping a lot of money into science and education. International Geophysical Year, 1957-58, pumped a lot of money into SunEarth Science. So Boulder was in a unique position, unplanned, to benefit from the largesse of much of what was happening in that early middle Cold War era. And I quote Quig Newton, who's a president of the University of Colorado, where, speaking of this era, he quotes from Shakespeare's Julius Caesar, where he talks about there's a tide in the affairs of men, and if you ride the tide, good things will happen to you.
It seems as if you've ridden a good tide of your own to get here, and Boulder has ridden a good tide of its own to get here as well. So what does the future hold for you in your work now that you've done this book?
As I mentioned, I still am passionate about science. I was, quote unquote, an expert in space weather. And so now I'm engaged in some research work on the history of space weather and Sun-Earth connection research, working with Dr. Greg Good at the American Institute of Physics. And I hope to pursue more studies in the history of space weather, including things that were going on in Boulder over the past 50, 60 years. Space weather is a fascinating subject. It has been going on as a serious science study for much longer than people think today. And it's has achieved sort of a new prominence because of the fragility of various infrastructures that have developed in the modern world. So it's just great science. It's got great personalities in it, like Walt Roberts, and there's still stories to tell, and that's what historians do.
I look forward to hearing your next stories, and thank you for sharing some here today.